All right, so here we go. Good morning, everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. You guys ready? Let's go. So today's agenda, we got warm up number 7. We're working on sum, difference, product, and also we're going to classify. It didn't fit there. Polynomials. And our home play for today is pages 276, 277 only. You see how I did that? You guys notice when I say only, it seems like very little work. Bam, let's go. So yeah, so here we go. And like I said, if it looks kind of pixelated at the beginning of the video, like I said, bear with me. Here it is, warm up number 7. And we have number 1, simplify, 1 and 2. Number 1 reads 7m minus 9x squared plus 10 plus negative 2m plus 5x squared plus negative 2 minus 5m. Number 2, negative 3, parentheses x minus 5 plus x, parentheses, negative 2x plus 6. For number 3, they want us to solve, and it reads negative 25 less than 4x minus 5 less than 7. All right. And a reminder, if you notice at the top left of your screen, it says tutoring reminder. So today, since I have periods 4, 5, and 6, your tutoring session is from 2 to 3. So if some of you feel like you need to act like tomatoes, bam, I'll see you there. Make sure you go to Canvas, to my page, to your period, and then underneath where you see the GIF where I'm like that, it says Mr. Q's tutoring, and then it says Zoom. Click on that, and it's going to send you to the Zoom session for periods 4, 5, and 6 from 2 to 3. And for periods 1, 2, and 3 are from 1 p.m. to 2 p.m. Okay? And once again, especially those of you that struggled in the past with algebra, and I remember when I explained it from elementary till now, that you still have difficulty with unknowns and variables, I need for you to attend those tutoring sessions. We go over the practice together, okay? All right? Show me with fingers how many more minutes do you need for the warm-up? 4, 3, 1, let's go. 4 plus 3 plus 1, that's 8. Divided by 3, that's 2 point something. So let's make it 2 minutos. 2 minutos, yes? And I see Megan. Hi, Megan. Bam, Game Boy Enrique, let's go. What happened to the headset? Devin, good morning. Let's see who else.
Good morning.
Ellie, morning. Okay. So let's see. Help me out with number 1. What'd you get for number 1? Kevin.
I got negative 4x squared.
Negative 4x squared.
Minus 8.
Minus 8. Hands if you got something like that. Close. Who saw the mistake?
It's plus 8.
It's plus 8. Thank you, Brisa. So yeah, just be careful when you're combining that you keep your symbols straight. Number 2. Let's see. What'd you get for number 2? Emily P. What'd you get for number 2?
Negative 2x squared plus 3x plus 15.
Hands if you got something like that. That is correct. And once again, let me go over this one just to make sure that we're getting our processes correct. We have a negative 3 in front of the parentheses. It's going to distribute to both terms. That's negative 3x plus 15. From there, I have a plus. I'm going to distribute the x into both terms. So x times negative 2x, that's negative 2x squared. I'm going to leave that in parentheses. And x times 6, that's positive 6x. From there, we combine like terms. I'm going to start with the highest power. The highest power is to the second degree. Is there another x squared? No, I just write it there. From there, I combine the x's. I got negative 3x and positive 6x. They're the same variable. And then I just look at the coefficients. What is 6 minus 3? 3. There it is. And then the constant goes at the end. There it is. Thank you. And then let's go to number 3. What'd you get for number 3? How about John? What'd you get?
I got -5 is less than x less than 3.
All right, hands if you got something like that. Yes, that is correct. Here goes the process for those of you that are watching on YouTube. Here we go. We need to simplify each expression. We can't simplify here, here, or here. So the next step, isolate the variable, which means we need to add 5 to each side, to all sides. We end up with -25 less than 4x less than 12. And last but not least, divide by 4, divide by 4, divide by 4. So what is negative? Oh, this is 20. I'm sorry, -20. What is -20 divided by 4? That's -5 less than 4 over 4 is 1. We're left with x. And 12 divided by 4, that's 3. And if I was to ask you to write it as a solution set, you would write what? Solution set of x such that, and then you close your solution set. Hands, have you got all 3? Yeah, let's go. All right, let's move forward. Here we go. Copy your asynchronous session code, AGFSP, AGFSP. And that's going to take you to Nearpod, and that will allow you to move the screen by yourself and the presentation. And once again, this code I give you just in case you get kicked out of Zoom or whatever reason, maybe you're a Power Ranger and you get, texted that you need to go save the world. There you go. So the second thing is that to remember always to go to the YouTube channel and make sure you watch the video lesson of the day. Make sure you revisit those lessons in case you are feeling that you're falling a little bit behind or it's going a little bit too fast. And once again, you attend the tutoring sessions. Okay. And when you log on to your asynchronous session, make sure you type in the period first. Look at that. I even put a big old number and then your first and last name. Why? Because that helps me keep organize all your periods together and I can look through your assignments a little bit faster. Okay. All right.
Mr. Q?
Yes.
My Nearpod says it's currently under maintenance.
Yes. Right now, Nearpod is not up. That's why we're not doing the live right now. That's your asynchronous code. Yeah. All right. Home play for tonight. Pages 276, 277, numbers 1 through 14 only. It makes it seem like it's very little, right? Let's go. All right. Let's move forward. Our objective for today, I can add, subtract, multiply, and classify polynomials. Once again, I can add, subtract, multiply, and classify polynomials. That goes at the bottom left of your screen. I mean, of your Cornell notes, I'm sorry. And today, we will get through addition, subtraction, and classification. Most likely, we're not going to get through multiplication. That's going to be in our next session. One thing I did want to address, guys, we turn in grades next week, so make sure you're keeping up with your work. As I'm going to go through the reports this weekend because I still have students coming in and out of my classes, and I'm waiting maybe till this Friday for the final report and checking all that. And I'm going to start uploading my grades so like that you can see your grades over the weekend. So make sure you keep up with your grades. Remember, we needed to turn in all the cumulative review assessments. I mean, not assessments, the home place. And I gave you an asynchronous code for that. Also, this week, today's home play, and also we're going to have a pop party. Let's go this week. You guys ready? Let's go. And all that's going in there. So make sure you're keeping up with your work. Same thing with your other classes. Make sure you keep going to Canvas, checking with your teachers to see if they've input any grades. As of right now, I'm going to tell you that I haven't published any of your grades, so you're not going to see anything till this weekend. Okay. All right, let's continue. So our main concept for today is what? Polynomials. Remember what I said? That from now on, they're not going to leave. So write that down. Polynomials, what are they? Polynomials, let's see if you remember, are monomials or sum or difference of monomials. Polynomials are monomials or sum or difference of monomials. Examples: 2x squared, negative 3x to the fourth plus 2, and x squared minus 3x plus 2. You're like, oh, I remember these, Mr. Q. Yeah, I know, right? Our favorite. Yes. Yeah, I remember I used to tell you. So once you're introduced to polynomials, that's it. You're going to be at Donut getting your Arnold Palmer and maybe a carne asada torta, an apple fritter or something. You walk out ready to go to the park, and in the alley, somebody calls you, you turn. It's polynomials. All right, here we go. So like always, guys, remember I like to first break down the term, and the term is a compound word. And once again, who remembers what poly means? Poly means what? Many. That is correct. That's what poly means. And then the last part, nomial, means part or parts. So according to the term by itself, a polynomial has what? Many parts. Okay. But some of you are like, Mr. Q, I don't remember what monomials are. Okay, so let's break it down. Do you recognize any words? Yes, this part. What does that mean? Part, okay. However, we have M-O, but I'm gonna add the first two letters of the other word, mono. Mono means one. So therefore, a monomial only has what? One part. So according to the definition, polynomials are monomials. So let's see. The number 2, it only has one part. Why? Because there's nothing adding or subtracting, being the sum or difference. So it's by itself, it's only one, it's a monomial. Let's look at this one, x squared. How many parts? One, because nothing's being added or subtracted. It's only a monomial, one part. So let me show you this one. I start here, and I stop whenever I see an addition and subtraction. There's the addition, so that means this is one part. This is another part. This is a monomial. This is a monomial, and they are doing what? Adding and subtracting. Is it coming back? Bam, let's go. Look at this one. I'll stop right there because there's a subtraction. I'll stop right there because there's an addition, and I'll stop right there because there's nothing else. How many monomials? 1, 2, 3. And they're adding and subtracting. That's why they're known as polynomials. All of these together, they're known as polynomials. Copy that. And then I'm going to give you some non-examples. See if you can remember why those are non-examples. Okay, now that we covered our definition. All right. Here you go. Non-examples. Copy these. 2 equals 2x. X squared plus 3x plus 2 equals 0. Negative 3 plus x equals 10. So by looking at them and you're writing them down, you're like, oh, I know why these are not polynomials, Mr. Q. Right? Am I right? Am I right? Am I right? Okay. So why are those not polynomials, Zach?
Because of the equal sign?
Because of the equal sign. Yeah. So these are equations. Therefore, if these are non-examples and they are equations, what do we call these, Zach?
Expressions?
Expressions. Bam. You remind me of me in kindergarten. So what can we conclude, guys? If you were to take a snapshot of this and send it out on your Insta or your Snap or your tweet or your Kick or your WhatsApp or whatever it is you do. Hashtag what? What would you hashtag this picture, Aiden? Hashtag what?
Hashtag no equal sign.
No equal sign. Thank you. Hashtag what? Yomara.
Hashtag expressions.
Expressions. All right, one more. And that one, see if you can think to when we started with these definitions right now. What would be the last thing that we would add? What are polynomials if you were just to say something simple? Let's see, Alvaro. Polynomials are hashtag.
Sum or difference of monomials.
Yeah, that's the whole definition. How about how about many parts? Many parts. All right. So now that we're done with definitions about polynomials and we know that polynomials are what? Expressions. We agree with that? Yes? Okay. So now I'm going to review and I'm going to refresh in your memory in regards to the parts of an expression. I want to make sure that when we're talking and we're going along that you're understanding every piece that we're talking about. Here we go. So parts of an expression. Here it goes. An expression has different parts. Each part is known as a term. Once again, an expression has a lot of parts. Each part is known as a term. Okay. However, how do you know when it is a term? Well, you start, and I'm going to show you a quick way of looking at it. You can start underlining from left to right, and you stop every time you see an addition or subtraction sign, and that's the end of one term and the beginning of another. So if that's true, we also have other terms that are known as like terms. What does that mean? Whenever a term or a part has the exact same variable with the exact same exponents, those are known as like terms. However, Mr. Q, what if it's a number without a variable? Well, those are also known as a term, but they're known as constants. They're known as what? Constants. Example, look up. So let's say I gave you 4x minus 3x plus 2. All right, so let me show you the little activity that I do so I know how to identify the terms. I start underlining from left to right, and I stop anytime I see an addition or subtraction. That's when one term ends and another one begins. Again, I stop wherever there's an addition or subtraction. That's when one term ends, another one begins. Since there's nothing else, how many terms do we have? 1, 2, and 3. 3 terms. Simple as that. Next, if I was to identify like terms, what did we see like terms were? Terms that have the exact same variables with the exact same exponents. Do you see them? Yeah, they're right here. 4x and negative 3x. Okay, so these are my like terms. So what do we call this one, Mr. Q, that does not have a variable? That's called a what? A constant. That is correct. Now, why is it called a constant? Well, let me go over this. Now, some of you might have forgotten. Let's see. Oh my goodness, sorry. Here he goes. A constant is known as a constant because if I was to give you a value for the variable, let's say I said x is 10. That means I substitute 10 here and 10 here. So it would be 4 times 10 and negative 3 times 10. And then I bring down the plus 2. Notice which term did not change? 2. Why? Because it stayed constant. That's why it's known as a constant. Okay, so this becomes 40 minus 30 plus 2. Did you see 2 change again? No, that's why it's known as a constant. So in other words, what is a constant? A number without a variable because it's not going to change till the last step when you simplify at the end if they're like terms, okay? All right, let's move on. Now, with like terms and terms that have variables, the number that's multiplying the variable is known as a coefficient. Let me repeat that again. The number multiplying the variable is known as a coefficient. So let's see. if I was to show you the variable, where are my variables? Right here and right here. So my coefficients are what? 4 and -3. Some of you are like, Mr. Q, but it's only 3. Yeah, whenever there's a subtraction sign in front of it, make sure you attach it to that coefficient. So my coefficients are what? 4 and -3. Is 2 a coefficient? No, because it doesn't have a variable. It's not multiplying anything. It's by itself. All right? Also, remember this. If I was to give you an expression such as this one, x squared plus x, whenever those expressions come up and there's a variable, remember that there's always an invisible coefficient, which is what? A 1. So make sure you write your 1 in case you start getting confused with combining like terms, okay? All right, show me with your fingers how comfortable you are so far with definitions of parts of an expression. 5 fours, 5 fours, okay? Yeah, we're there. All right, so now that we're done with that, let's see how we do with a little exercise with parts of an expression. Copy this, please. Example Q. And we got 6x squared minus 5x plus 4 plus x squared. And then underneath, don't copy all the questions, just write the letter A for that first question, B for the second, C for the third, D for the fourth, and Q for the last one. See what I did there? That's pretty good, right? All right. So let's do this one together. See how we did with understanding the parts of an expression. Here we go. I'm going to start with blue. It says how many terms? Okay, I'm going to start underlining from left to right, and I'm going to stop wherever I see an addition or subtraction. So let's see. Stop right there. This one ends. Another one begins. Right there. Stop right there. Ends, begins. Right there. Ends, begins. Ends. How many terms? 4. You're like, oh, I get it, Mr. Q. Yeah, I know. Next, I'm going to use red. Like terms. What does that mean? Terms that have the exact same variables with the exact same exponents. So what are my like terms? 6x squared, comma. What's the other one? 1x squared. Yes, exact same variables, exact same exponents. Constant. I'm going to use green. What's my constant? A number without a variable. Which is that? This one right here, 4. Okay. Coefficients. All right. How do I identify coefficients? By looking at the variable and looking what numbers multiplying the variable. Let's see. I'm going to use black for this one. Coefficients. So my first variable is right here. So my coefficient is what? 6, comma. What's my other variable? X. So what is my coefficient? -5. That is correct. Remember what I said? Don't forget to include the negative if it has a subtraction in front of it. And what's my last coefficient? 1, because it's invisible right there. Okay. Last but not least, we need to identify the leading coefficient. All right. For identifying the leading coefficient, there's a couple of steps. The first step, let's see if you guys remember, we need to write it in standard form. Standard form. What does that mean, Mr. Q? We need to write it from greatest to least, but we also need to combine like terms. So here we go. I'm going to do this. I'm going to combine this one. This is the x squared with this one because those are like terms. So what is 6 plus 1? That's 7x squared. Okay. Next, I'm going to go with the x. Is there another x? No. So I write -5x. And what's my constant? My constant is +4. Okay, now that we have it in standard form, what is standard form? From highest to least degree. Okay, I need to identify the leading term. If we read it from left to right, what's my first term from left to right, or my leading term? This one. But what do they need? They only want what? The coefficient of that leading term. So what is my leading coefficient? 7. Is it coming back? Yes? All right. Copy that, and I'm going to give you one, see how you do by yourself. Here it goes. Example super Q. And there it is. X squared plus 10x minus 3 minus 8x. Example super Q, x squared plus 10x minus 3 minus 8x. Oh, sorry. Oh my goodness. Okay. Once again, A, B, C, D, Q. Answer those questions, see how you do. By the way, do you guys see MJ in the background? Let's go. All right, let's see. How many terms in the expression? Eric.
Not done.
Okay, we'll look at it.
Four?
4, thank you. How about what are the like terms? Lizette, like terms.
X squared and
Is there another x squared?
oh no, sorry, I meant 10x and 8x.
10x, comma, and
Negative 8x.
negative 8x, thank you. What's our constant? Daniel.
The constant is -3.
Negative 3, thank you. What are our coefficients, Manny?
1, 10, and -8.
That is correct. And if we were to simplify this, you should have gotten x squared plus 2x minus 3. Therefore, our leading coefficient, here's my leading term, my leading coefficient is 1. Hands if you got that by yourself. Let's go. Yeah, we got this, yes? All right, so we're done with the review. And notice, guys, and I'm bringing you back the way I instruct. I try to get you guys closer little by little before we even get started with the lesson. So now we're going to start with the lesson now that we did all the review. Okay, so here we go. So today we're getting started with your favorite. Some of you remember this one. We're going to classify polynomials. What is that? We're going to name the polynomials. You guys remember this? Yeah. So how do we name them? They have a first and a last name. They have a first and the last name. And I don't know if you noticed, I put first name in red, last name in blue. Why? Because remember, I actually made a table for you guys. You're not going to find it anywhere. Mr. Q made it. Here's the table. You guys remember that one? Yeah, let's go. It's coming back. Hello. So according to degrees, we have, if the polynomial has 0 degree, it's a constant. First degree, it's a linear. Second degree, quadratic. Third degree, cubic. Fourth degree, quartic. Fifth degree, quintic. Anything after that is to the degree. So 7th degree, 10th degree, and so on and so forth. However, the last name is according to number of terms. If it has 1 term only, it's a monomial. It has 2 terms, a binomial. 3 terms, trinomial. Anything after that is just known as a polynomial. Okay? So check this out. Copy this one. Example, I'm going to make this example Star Wars cube. Let's go. All right. We got negative 2x plus 3x squared y squared plus 1. All right, just copy it. You don't have to copy anything else. Writing utensils down, look up to the screen. Here we go. I'm going to refresh in your memory, and then I'm going to give you one for you to do. If I have a polynomial like that and I want to classify it, first thing I want to do is make sure it's in standard form. Is it in standard form? No. So that means I need to identify all the degrees. So check this out. The degrees is by looking at the variables of each term. Look at this term. What is the exponent on that variable? 1. So this is the first degree. Look at this one. You're like, Mr. Q, but there's 2 variables and there's 2 exponents. So what do? We add the exponents of both variables. So what is 2 plus 2? 4. Does this one have a variable? No. So if it doesn't have a variable, it's 0. Now I can write it in standard form. Check this out. I'm going to write this first, 3x squared y squared. Then I got negative 2x, and at the end I got plus 1. Now I can classify it. What's my highest degree out of the entire thing? And no, I'm not going to add these numbers down here. I'm looking at the highest number. What's the highest number? 4. So if it's 4, what's the first name of this polynomial? Quartic. All right. How many terms does it have? Let's see, 1, 2, 3 terms. So what's the name according to the term? Trinomial. So if you want to make sure, just make sure these 2 match up here and here. You write that quartic first, trinomial second, and that's how you get the name. All right, copy that, just the top, and then I'm going to give you one for you to practice. Here we go. All right. So, example MJQ. Let's go. Ready? We got negative 2x cubed plus 5. Let's do minus 3x squared y cubed plus y. Let's see how you do with that one. Once again, step 1, standard form. Step 2, make sure you go with the degree first and then the number of terms. In the meantime, let me have some coffee. Let's go. Look at my cup. Let's go. Man, that's good. All right, let's see. What'd you get for standard form? Paul, standard form.
I got negative 3x to the second power y cubed.
Uh-huh.
Minus 2x cubed.
Uh-huh.
Plus y plus 5.
Yes. Plus 5. Hands, have you got that? Yes. All right. So the highest degree was what, Yoann? You're muted. You're muted. Okay.
Excuse me?
Highest degree?
Highest degree. It's
Okay, so let me go over this. This is third degree, 0 degree. 2 plus 3, that's fifth degree, 1 degree. And what is the highest? 5. So this is a what? Quintic. All right, thank you. How many terms, guys? 1, 2, 3, 4. So if it's more than 3, what is it called? Polynomial. Hands, have you got that? Is it coming back? Yes? Yeah, right? Yes, Mr. Q, we love these. All right, good. And so on and so forth. So once again, you have the asynchronous code where you can go and look at the table. You can copy the table. You can take pictures of the table, take a selfie with the table, and so on and so forth. I'll leave that for you at your discretion. But let's move forward. Because look, you're going to get problems that look like this. Look up. You don't have to copy that, but look at it. Classify the polynomial. Well, they're going to ask you for the degree of the polynomial. The degree of the polynomial is the highest degree. And they're not going to give you a table. I gave you the table so you can get used to how to find the name. But you need to memorize those names by degree and by term. Okay? All right, let's get started with the funner stuff. Yeah? Example 1. Copy this. Add or subtract the polynomial. We got parentheses 9b plus 5a squared b minus 3a squared plus 5, close parentheses, plus, open parentheses, negative 7a squared minus 2a squared b plus 2b minus 1, close parentheses. Once again, they're asking if we're adding to add or subtract. So we're done with classifying. Now we're going into addition and subtraction, okay? Because it was part of the objective. So here we go. Writing utensils down, look up to the screen. Here goes a recap. See if you remember. First things first. Who noticed now that we're not just combining terms? Now we have two different expressions. Here's one expression on the parentheses here, another one over here. And what is the sign in between those two expressions? An addition sign, which means we're going to do what? We're going to add the polynomials. Whenever we have an addition between two polynomials, check this out. We don't really need to worry about the parentheses because there's nothing outside to multiply anything inside. All we have to worry about is combining like terms. So here we go. I'm going to start with blue, and I'm going to start with 9b. Is there another b? Yes. So what is 9 plus 2? 11b. Next, I'm going to go with red. 5a squared b. Is there another a squared b? Yes, over here, Mr. Q. Okay, so I'm going to write a squared b because they're the same variable, same exact exponents. And what happens to the coefficients? Well, we look at the coefficients. What is 5 minus 2? Positive 3. All right, next. I'm going to go with a squared. Is there another a squared? Yes, right there, Mr. Q. So I write a squared. And if we're adding and they're the same sign, we just combine them. What is negative 3, negative 7? That's negative 10. And last but not least, I'm going to underline the constant. We have 5 and negative 1, so that gives us positive 4. We combine like terms, copy that, and we have one more step to go. Writing it in what? In standard form. Do you guys know how to write in standard form? Yeah, we just did that earlier. So copy that, and then let's do the standard form together. All right, for standard form, I need to identify all degrees. This is, the exponent on the variable is 1. This one, the exponent on the variables is 2 and 1, so 2 plus 1 is 3. This one, the exponent on the variable is 2. And this one doesn't have a variable, so it's 0. And I just rewrite it. I start with the highest variable, which is 3, so it's 3a squared b. I'm sorry, the highest degree. From there, the next degree is 2, so I write negative 10a squared. From there, the next one is this one. And since it doesn't have a sign, that means it's a positive 11b. And last but not least, we got plus 4. And we just, what did we do? We added a polynomial. Show me your fingers, I'll come to you over these. Should be coming back already, yes? All right, good. See how you do one by yourself. Ready? Here it goes. Copy this one. Example 1Q. We got 9b to the fourth plus 5a squared b minus 3a squared minus 3, close parentheses, plus 9a squared minus 2a squared, 2ab squared plus 2b to the fourth minus 4. Let's see how you do with that. 1 minute or 2 minutes, 2 minutes. All right. Yes, Mr. Q, I love these. Yeah, let's go. You probably have a poster in your room with some of these, huh? Let's go. All right, so let's see. I'm not going to put anyone on the spot. I'm going to go through the process just to make sure we got it. First thing we check for is what are we doing in between these two expressions? We're adding. So we need to just focus on combining like terms, not worry about the parentheses. So I'm going to start with the first one. I'm going to start with blue. B to the fourth. Is there another B to the fourth? Yes, Mr. Q. So what is 9 plus 2? That's 11. B to the fourth. All right. Next, I'm going to go with red. Positive 5a squared b. Is there another positive 5a squared b? No. Some of you made a mistake and you combine it with this one. Look at them. They have the same variables, but they do not have the same exact exponents. Be careful with that. So I'm going to write this one right here, plus 5a squared b. All right, next, I'm going to go with a squared. Is there another a squared? Yes, right here, Mr. Q. There it is. So I'm going to write a squared. And then I got -3 and +9. That's +6. Okay. Next, my constant. I got -4 and -3. So that's -7. And what's the only one that's loner by itself? This one right here. So I write -2ab squared. Okay. Am I done? No, I need it in standard form. So let's see. What degree is this first term? 4. What degree is this term? 3. What degree is this term? 2. What degree is this term? 0. What degree is this term? 3. You're like, so which one's going to go first, Mr. Q, from those two that are third degrees? We'll just put whichever one because they're the same degree. So I'm going to start here. I'm going to write 11b to the fourth. Then I write plus 5a squared b. Then I write -2ab squared. Then I write +6a squared. And at the end, -7. Hands if you got that by yourself, by the way. Let's go. From the corner. I remember when I was going through these in kinder, I think it was. So, all right. So we're done with addition. Show me with your fingers how come you are with addition. Yeah. And all they do, guys, all they're going to do in the text, they're probably just going to add one more expression by putting plus another expression. So you're going to have 3 expressions, but it's the same process. Okay. All right. We're down to the last one. Ready? Copy this one. Example 1 super Q. We got add, subtract polynomials. We got 9b plus 5a squared b minus 3a squared plus 5 minus parentheses -7a squared minus 2a squared b plus 2b minus 1. Okay, let's do this one together. And you're going to see the only difference from these to the ones that we just did is here. Here it goes. What is the first thing we check? To see what's in between the two expressions. What do you see? Subtraction. So for this one, we're going to subtract. What's so important about this one? Let's see if you remember. Whenever there's a negative, in front of the parentheses, there's an invisible one there. We need to distribute that to all terms inside of the parentheses to the right of that, because it's multiplying. All right, or in other words, it changes all the signs to their what? To their opposite. So what is the opposite of -7? Positive 7a squared. What's the opposite of 2? Of -2, it's positive 2a squared b. What is the opposite of positive 2? -2b. And what is the opposite of -1? Positive 1. At that point, guys, we no longer need this. So like that, you don't get confused. So we're going to focus where? Here and here. And all we do is combine like terms. Combine them, find it in standard form, see what you get. All right, let's see. Degree, I'm sorry, B, is there another B? Yes, over here. So 9 minus 2, that's 7B. From there, I'm going with 5a squared B. Is there another a squared B? Yes, right here, Mr. Q. So what is 5 plus 2? That's 7a squared B. Next, I got a squared. Is there another a squared? Yes, right here. I'm going to write a squared. So what is 7 minus 3? 4. And then I'm going to underline the constant. I got 5 and I got 1, so that's positive 6. And my last step, standard form, 1, 3, 2, 0. Therefore, my standard form is 7a squared b plus 4a squared plus 7b plus 6. Let's go. Show me a famous who got that one by yourself completely. Yeah, we got this. Yes. And that's the home plate, guys. Classifying, adding, and subtracting. So with all three things, show me with terms from 1 being the lowest, 5 being the highest, how comfortable you are with these. 5 tens, 5 tens, 5, 5, 5, 5. Yes. Some of you need a Manny or something. All right. So just to recap, guys, once again, I'm going to go to the agenda once again. Oh, sorry. Okay. Anyways, not letting me go to the agenda. However, the home plate for tonight is on pages what? 276, 277. Okay. So I'm going to go ahead and get and stop right there, guys. I know it took us a bit just to finish. And like I said, we're going to get to multiplication when we meet again. But remember, go to the YouTube channel and act like tomatoes, please, because grades are coming next week. I want to make sure that you've turned everything in, especially those of you that barely made it to you transferred to my class. Make sure you're caught up, please, pretty please, with a cherry on top. Also, once again, if you feel that you're going to need support for the home plate, today I'll see you between 2 and 3 for periods 4, 5, and 6. And once again, for periods 1, 2, and 3, I'm from 1 to 2. Okay? With that said, I'll see you guys next time, guys. Keep up the good work. See you guys tomorrow. No, Friday. Let's go. Peace.